continuing on with our mathematics review, starting at number 14. Population math. What do you remember about population math? Alright, so population math, you basically take births plus immigration minus deaths plus emigration over total population. So our births here are 100,000. Our immigrants are 30,000 minus deaths at 70,000 plus our emigrants with an E, 50,000 over the total population, which is 6 million. 6 times 10 to the 6. Alright, 100,000 plus 30,000 is 130,000. Minus 70 plus 50 is 120. So this is 10,000. So let's put this all in scientific notation to make it easier. So I'm going to move the decimal point 1, 2, 3, and 4. So it's 1 times 10 to the 4th divided by 6 times 10 to the 6. So 1 divided by 6. So doing it long division, you're going to have to do something like this. Once you finish this division problem all the way out, you're going to end up with 0.17 times 10 to the, well, 4 minus 6 is negative 2. So putting it into proper scientific notation, let's not put in scientific notation at this point in time because it's asking for the growth rate in a percentage, and this came out not in a percentage at this point in time. So let's actually take this out of scientific notation right now. So to get rid of to get something out of scientific notation, I'm going to move it this direction twice, so I can move it in a positive direction once, twice, and then I can add that 2 to this. Positive 2 plus a negative 2 equals 0. So that's how I took it out of scientific notation, 0.0017. Because here I think it's easier than to figure out what the percentage is. So this is actually the growth rate. This is R right here. R equals 0.0017. Now this is a correct answer for R. We can also put R in a percentage, and the question here asks you for it in a percentage. So now we're going to put it back in not scientific notation. We're going to put it back into a percentage. Well, actually it's not even back into a percentage, it's just into a percentage, and so it's 0.17%. So 0.17% is the growth rate. 15 is asking for doubling time. So the rule of 70 is 70 over R when R is a percentage, like this. So 70 over 1%, it's going to be 70 years. And that's it. Alright, this one is giving you that it's doubling in 20 years. What's the growth rate? So 70 over R is equal to 20 years. So if we just solve for R, we get 70 basically over 20 is equal to R. And 70 divided by 20 is equal to 3.5%. And since we use the rule of 70, it comes out as a percentage because R, you use the rule of 70 when R is a percentage, so it comes out here as a percentage. Where would this country be? Well, if it's doubling in 20 years, is Europe doubling in 20 years? No, it's actually most of the countries are shrinking in population, so this is going to be sub-Saharan Africa. Alright, for this one, it's a tricky rule of 70. So our growth rate, first of all, let's find out how long it takes to double. So 70 over R, our growth rate is 7%. And so it's going to double every 10 years. So it's going to go from 20,000 to 40,000 in 10 years. And then to 80,000, because 40,000 is going to double again in another 10 years. But it asked us at 60,000, so it's going to be halfway between. So it's 10 plus halfway would be 5, and so our answer is going to be 15 years. So 10 plus halfway here, it's going to be 5, so 10 plus 5 is 15 years. Alright, next page. The next couple of problems are pretty hard. Occasionally you see something this hard on an FRQ. So let's go ahead and go over it. Well, I guess they're not terrible. How much energy is required to raise the temperature of 1,000 gallons of water by 25 degrees? Well, let's look at our givens here. Go ahead and read those over. So we're going to start with 1,000 gallons. And it gives us that 8 pounds per gallon, because it tells us here. So now my gallons can cross out, so that's good. And so we end up with 1,000 times 8, so we have 8,000 pounds of water here, and it tells us that we're going to raise it by 25 degrees Fahrenheit, and 1 BTU is the energy required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. So this is kind of weird because you just multiply here by 25 degrees Fahrenheit, which gives you here 200,000 BTUs. So what in the heck? We have pounds and Fahrenheit give you BTU. So this is a weird one, and I just wanted you to be aware of this so you can attempt it on an FRQ, because pounds plus degrees change here in temperature is actually the definition of a BTU. So when you multiply pounds and your temperature change, you end up with BTU. So it is, again, an exception to how we've always been doing the units before. And again, this is pretty difficult. You won't see something this hard in the AP test, but it is, technically possible. All right, this next one is, we're going to start with 1,000 kilograms times 2.2 pounds per 1 kilogram. And that's going to give us 2,200 pounds. Well, first of all, I didn't go back and tell you that a metric ton, when we went back to another previous problem, it told us that a metric ton was equal to 1,000 kilograms. And so, I'm sorry, I didn't tell you, that's how I have this number here. So we have 2,200 pounds of water. And again, it's using this weird pounds and temperature and BTU. So this time I'm going to take 1,110,000 BTU divided by 2,200 pounds gives me something degrees Fahrenheit. And again, that's just rearranging pounds times degrees Fahrenheit gives me BTU. Well, this time I have the BTU, and the pounds and Fahrenheit have to go together, and so I can use it in this way. And so when you do this division problem, you end up with 50 degrees Fahrenheit. So just to clarify, you have pounds times degrees Fahrenheit gives you a BTU. So this time I had BTU and I had pounds. So my pounds I can just put over on this side, and so I have BTU over pounds gives me Fahrenheit, because these will cross out. And that's how I did this equation here. And the last one of this ugly math is we're going to take 500,000 BTUs using, divided by, 80 degrees Fahrenheit, because again, this time we have BTUs and Fahrenheit, so this time the Fahrenheit's going to be here and the pounds are going to be here. So BTUs divided by 80 degrees Fahrenheit, because we're going from 20 to 100, which is an 80-degree change. And so that's where we're going to end up with pounds. So 500,000 BTUs divided by 80 degrees Fahrenheit change gives us actually 6,250 pounds. But we need to know how many gallons that is. And so we go back up here to 8 pounds per gallon. And we change this to 1 gallon over 8 pounds. And so 6,250 pounds times 1 is, not times 1, divided by 8 is going to give us 781 gallons. Alright, the last one is percent change, and if you remember percent change, it's starting amount minus ending amount. Nope, I have that flipped. It's ending amount minus starting amount divided by the starting amount. So our ending amount is 360 minus our starting amount is 240 parts per million divided by our starting 240 parts per million. And remember to put your ppms. Always put your units in your math. So we have 120 divided by 240, and you can just eyeball that. 120 divided by 240, it's just 50%. And so that is our percent increase. Okay, same thing with this one. Our ending amount is 260, pardon me, minus 312 divided by 312. And that gives us negative 52 over 312. And so this which shows us that it's a decrease. And so we have a negative 17%. So negative 52 divided by 312 gives you negative 17. So this is the percent change is a negative 17%, or we can say that it's a 17% decrease. Now the second part of the question is how much percent per year? Well, it's from 2008 minus 2001 gives us 7 years. So we can take this number divided by 7 years, and we end up with 2.4% decrease per year on average here. And so you end up with two answers. So you could say either negative 17% change or a 17% decrease, or this is a 2.4% decrease per year, or a negative 2.4% change per year. And however you word that is correct in either one of those ways. Last but not least, toxin increases from 12 to 40, so 40 parts per million minus 12 parts per million divided by your starting amount, 12 parts per million, and we end up with 28 divided by 12, and go ahead and do that long division, and you end up with 2.33. Let's go ahead and put this in a percent. With the decimal point twice over, it's a 233% increase. And that's it.